Yeah.
So it says create three deductive arguments for some conclusion. So does that mean like three arguments for the same conclusion?
No, for different conclusions, yeah. Well, I mean, I guess it could be three arguments for the same conclusion, I don't care. If you had three different arguments for, say, the existence of God, that's fine with me. That's one conclusion, but three lines of argument, right? Yeah, so that would work. Yeah, good question, I didn't think about that.
So what was the extra credit message you sent out earlier?
Uh,
The argument thing?
Yeah, so I just want you to make where's my adapter? I just want everybody to make, for who wants to do it, three deductive arguments for different conclusions, or same conclusion, but three distinct deductive arguments for some position. Put in standard argument form, translate it, prove that it's valid. And then over the next few weeks, we'll do like maybe one or two a week. And I'll just cold call somebody and say, bring your argument up, put it on the board, write it out, explain it, and then prove that it's valid. And then let's talk about the shortcomings or strengths of your argument. And what you'll very quickly see is that it's way harder than it looks. And that even if you can do the logic, there are other considerations to argumentation that are very difficult. So, sort of like an opportunity to practice and actually apply the skills we're learning in this class. If that makes sense. Wow, that's long. Okay. Everybody hear me? Is that okay? I can turn it up, I can turn it down. Doesn't matter. We still got 2 minutes. Am I recording? I don't even remember. Let's see. Yes. How's it?
The one in the student union is so much worse.
Really? I haven't looked.
Like, when I'm looking, like, you can see, like, from the previous, like, meetings or whatever was held in there, like, the fake outline.
Also with all those windows in there and like the time of day that we're like in there, it's always so glary. It's like right on the board all the way. I'm like, bruh.
I accidentally wrote on a chalkboard the other day with a marker. So that was not one of the jerks ruining the boards. It's hard, like because I'll just have either chalk or a pen in my pocket, moving between classes, and I'll just really quickly grab it and start writing. I'm like, oh no, man. Because they have to like resurface the boards when somebody does that. Like they have to like sand, if it stays on there, they have to like sand down the chalkboard and polish it.
Oh God, I can't
Yeah.
imagine the sound.
Oh yeah, horrible, right?
Why would you bring that up?
Yeah. They have to, I mean, we take it for granted, but like on the weekends, like normally, yeah, I mean, even this one, it's a little bit smudgy, but every weekend, there's like people, the janitors, that come in and just focus on like, this board has to be like completely wiped of residue. It's crazy, yeah. It's like, there's actually people who those are their jobs. They go through the buildings and like, are being janitors, cleaning these, surfacing the chalkboards and stuff. That must suck. Okay, any questions about anything we've done so far, 7.1, anything in class in general?
I have a question.
Yeah.
Okay, so earlier I was making up some arguments of my own, and I was wondering with the hypothetical syllogism if you could have like H implies T, T implies M implies N, therefore whichever letter I said first implies N. So like kind of skipping a step, would
Right.
you be able to just say like lines 1, 2, and 3 hypothetical syllogism?
Yeah, so if you had something like this, right? Well, let's say Cuban V. What you're rightly understanding the meaning of hypothetical syllogism and why it works, and you can clearly see that there's middle terms here. H is linked to T, T is linked to R is linked to Q, so you've got all these relations back to H. Yeah, I mean, it's completely logically valid to conclude that. Does it fit with our rules? No. But a lot of the stuff I do in this class doesn't fit with the rules in the book, because the rules in the book are like way too strict. Like with the double negation stuff I described last time, right? So yeah, if you did that in a problem or something, I'd be like, yeah, no point in going, you'd have to do like 4 different hypothetical syllogisms there, right? To do all the intermediate steps. Yeah, I don't think you should have to do it. But technically, the book says that's how you're supposed to do it, so. Any other questions? Okay. So, well, you've already got an argument. Do you have an argument you want to share?
Oh, sure.
Let's come up to the board. Let's do this.
Okay.
That sounded more like a no, but and then sure.
Well, it's
Yeah.
like a little bit of a crazy argument, and I don't actually know what it means because it's just symbolic. It doesn't have anything it really stands for.
So yeah, the point of sharing these arguments is just to show you how big of a task it is to try to come up with an actual argument, you know. And then you could approach this, you know, project, this extra credit stuff in 2 ways. What I think you're about to do is you're going to have a purely formal argument with some conclusion. Do these letters represent anything to you?
No.
No.
I was just putting letters in.
Yeah.
It was more about the structure than.
Well, try to then, on this extra credit assignment, put this up for now, and then try to plug meaning into there and see what you can get. I don't know what it would be, but you could either approach it from the symbolic portion first and then find an argument that fits that form. Plug things in until it makes sense. Or you could find something that, you know, you start with words and you translate it. Okay, your conclusion is Y or N. Can you prove that this is valid
I believe so.
with our rules?
Not without rules. I don't think so.
So can you do it with just the first 4 we've learned so far, you think? Okay, go ahead and show us. So you've got not T, where's that coming from?
Not T because if we have not A, we have this deductive syllogism here. So if not A, I must have
Good.
T. And then I'm gonna go ahead and skip this step like you said I could. So I've got
Yeah.
not Z implies T. That would be 2, 3, 4 hypothetical syllogism.
Yeah, and what you could call that is like what my old professors used to call is like doing a double call or even a triple call, right? Where you're like combining 3 moves in one or something like that. Yeah, that works perfectly fine.
Okay, and then if I have not T, then by modus tollens, I have Z, or not Z.
Right, good.
And if I have Z, then I have A or Y or N. And that comes from the first one and number 9.
Good.
That's modus ponens. And then I have not A, so by the disjunctive syllogism I must have Y or N.
Nice. That's a good proof. Good job. That's good. Beautiful. Yeah, good snapping. I like it. Good job. Did you make this one up?
Yes.
I don't know what the hell you'll be able to find that fits in there,
I don't know.
but I dare you to try. Let's see. I mean, you could figure something weird out, even if it doesn't make that much sense. It'd still be valid, technically.
Yeah. I
Good.
feel like that's half the ones in the book.
Oh, yeah. No, I've never seen, like, real philosophical arguments like the format in the book. Like, they're all so convoluted, right? Cool, that's great. Good job. Yeah, sure, if you don't mind. Good job. All right, any other questions or anything we want to go over? Any particular homework problems we want to do? Or does anybody have another argument to share, whether it's written in English or it's symbolic that you've made up? Has anybody else worked on like an English written argument yet?
I
okay.
have the symbolic ones from 7.1.5
Okay, cool.
that we have.
Yeah. So 7.1.5, if I'm remembering right, that just asks you to construct how many was it?
Four that use at least 3 different rules.
Okay. You want to come put one of those on the board and then show us how to prove it? That's good practice, and it kind of
Sure.
combines multiple things to practice into one.
Sure, they're pretty simple, so they should be easy.
They should.
They
Doesn't mean they
should.
will.
That's also what mine came from. Mine was the 7.15.
Yeah.
Okay, someone pick a number between 1 and 4.
3.
3? Okay.
Get her in teacher mode. What grade do you want to teach?
High school.
High school.
High school English.
Cool.
Because I was an intern in an elementary school this past year and I
Didn't like it?
no. I mean, it was fine, but I like high school more.
You get to teach more content.
That too. Okay. So, O or
You didn't fill that arrow in all the way, Sophia. Yeah, you got it. Good, there you go. Oh, you still missed, okay, that's fine, that's good enough. There you go.
there. Number 2 we have
That'll lose points on the test, for sure.
well, luckily
Just kidding, you don't actually have to do it.
no, that it's now you've got it stuck in my head.
You can just write arrows like I do, or you just do,
That's
you don't have to fill it in. Oh, you don't like my way of writing arrows, okay, I get it. Fine.
all right. So we have our 3 points, our 3 premises, and we're trying to get to not Q. So, anyone want to take a guess to how many steps it's going to take? 3 or 4? So we're going to get to 6 or 7 is what you're thinking? Yeah? Okay, let's see. All right, so what do we want to do first? What's the easiest thing to do with this? Because we know we have not O, so what can we plug that into? 2. And that would give us what? E, or not E.
Good game.
So that's 2, 3, and what rule is that? That's modus tollens, yeah.
It'd be so funny when you're teaching high school and talking to them like that, and they're like, shut up.
No, they're gonna have to suffer. Okay, so now we have E, and so what can we do next?
You also know that you have Q implies not E.
Yes.
1 and 3.
And which lines and which rules?
1 and 3 disjunctive syllogism.
You still got some like blank spots in the arrowhead.
If that's what causes me to fail this class.
Just use the horseshoe.
Exactly. Or write the arrows like I do, but apparently it's not good enough.
Okay, so now we have Q, not E. So what do we think we should do next?
Well, we can derive not Q.
Can we?
Yes.
Yeah.
Tell me how.
Because we have E.
E. Okay. Walk me through it.
See, this is good, I like this, that's
you
great.
Have, you have a 4-5 modus tollens.
Ponens or tolens?
Tollens.
Tolens.
That 5 was very clear, Sophie, and I'm sure you're right, it's okay.
Alright, so you're saying this should be what, not Q?
Yeah.
Yes.
Nice, good.
And that makes sense because this is also, we'll think of it as not E, if that helps you visualize that.
Does everybody see why that makes sense, the not, like the double negation thing? Does anybody not get the double negation stuff?
I'm a little lost on it.
Okay, so if I say to you, it's not the case that it's not raining today, what's that mean?
That it's raining.
It's raining, right? So if this is the necessary condition for Q, right? So in order to have Q, it's necessary that you don't have E, that not E is false, right? Or E is false or not E is true. So if I have not E, that's just negating this right hand side, right? So then that means you wouldn't have Q. Does that make sense?
Yes, yes.
So if I just write E, it's the same as not E.
Okay, that makes sense.
Clear up? Okay. Because the book doesn't let you do this until you get the double negation rule. It's stupid. But yeah, that's completely correct. Cool. Good job. Everybody snap. Yeah, I like the snapping. It brings me back to high school. In high school, my Brit Lit teacher was like such a fun lady. She was like so into British literature and like poetry and like poetry readings that she would have us all do that. That class was awesome. I missed that class. All right. Anybody else want to share one of the arguments you made up there? In what was it? 7.1.4? Yeah, 5. Anybody else got anything you want to share and prove?
I feel like no one can ever follow Sophia because it's just so entertaining.
Yeah.
Like nobody else.
You've got comedy, you've got instructions, good.
Yeah. See, that's why you need that's what you need in a good teacher.
Exactly. Somebody to learn from and laugh at the same
There
time.
you go.
Laugh with.
There.
No. Okay, well, if nobody wants to volunteer to share any more, I say I introduce the second set of rules right now. And we start practicing with those. So, okay, what are my first set of rules that we have? Somebody tell me.
Modus ponens,
Good?
modus tollens,
Good?
hypothetical syllogism, disjunctive syllogism.
Okay, cool. The second rule set is 4 more very similar rules. And we've got constructive dilemma. Sophia, it seems like you remember this well, so stop me if I'm getting the order wrong. Constructive dilemma, then you've got, what else do you have? Conjunction,
Yep.
Yeah.
simplification,
Uh-huh.
and addition.
Yep.
Yes.
Okay. Think them straight. Because I just taught the last 2 sets of rules today to my symbolic logic class, which is 10. Okay, so let me give English explanations of each of these. Constructive dilemma goes like this. Square then triangle, or circle then, oh god, trapezoid?
Yes.
Right? I'm going to remember
Is
someday.
this for constructive?
Yes.
It's and.
Is it and?
It's and.
Oh, you're right, thank you. That actually makes perfect sense. Maybe you should teach the class.
I just have notes in front of me, so don't feel too bad.
Oh, I don't, trust me. I don't feel bad about anything. Okay, so if I have this set up, what conclusion can I draw from this? Sophia, sharing the rules.
Triangle or trapezoid?
Why?
Because they both go into the conditional statements. The square and the circle do.
That's too imagistic describing it. I know you understand it, Well, describe more in a full-blooded way exactly why this works, if you can. I know it's hard to. This is a hard one to explain.
It's like you're in your head simplifying, so the first line, the two statements are on their own line since there's that conjunction. So you can simplify it, and then if you have the or of the antecedent of both, then you have the or of the consequent because of modus ponens.
Okay, closer. But why is that true? Why do you have, if you have the or of the antecedent of both, why do you get the or of the consequent of both? But that's a correct description of what it is. Yeah, you're right. But why does that work? Now I can set up a truth table. Do any of us want to see, what would that be, a 60-line truth table right now? You want me to do it? No? Okay, I won't do it. Thank you. Or I can have Sophia do it or something. But why does this follow from this?
Because if you have, say you have, so it's square or circle. So say you have square. Square is the sufficient condition for triangle, but it doesn't necessitate triangle. Or wait.
It does necessitate triangle.
Okay.
So,
Wait.
Is it something with like, it's basically like two modus ponens together? That's how the book described it.
Yeah, it's like two most ones, but it doesn't give you anything definite, right? We're not committed to anything here. So here's how I describe it. Look, you've got these two things are true. Square is sufficient for triangle, circle is sufficient for trapezoid. I know I'm going to have one of these. So no matter what, I'm at least going to have one of the sufficient conditions, which means I'm going to have one of what they get me, right? At least. Does that make sense? I mean, that's about as clear of an explanation I think anyone can give without giving a truth table. I can give an example of this in English. Oh God. It might be more confusing than just looking at it. Let's say if I get gas, and no, I'm not talking about farty, I'm talking about in my car. If I get gas in my car, then I will go to the store, and if I get let's say a new tire, then
You'll get an oil change.
sure, I'll get an oil change. I'm gonna either get gas or I'm gonna get a new tire. So if I were to get gas, then I'd go to the store. And if I get a new tire, then I'm gonna get an oil change. Maybe both could happen, right? There's nothing contradictory here. Well, I'm gonna at least get one of a gas or a tire, a gas. I'm either gonna get gas or a tire, or maybe both. So that means I'm either going to go to the store or get an oil change. Right? Or maybe both. Same exact form there. Does that make sense in English?
Yes.
What clicked for me was, at first I was wondering why it wouldn't be triangle and trapezoid, but then I realized that you could say like I have square, but if I didn't have circle, then if trapezoid was also false, then that would still make the statement true, and that's why it's
Yeah.
it's at hand.
Exactly. Good. Good click moment. I like that. Any questions on this one? Okay. So there's constructive dilemma. Here is conjunction, and this one is extremely simple. Let's say I have a premise that says P. Let's say I have a premise that says Q. What can I conclude from that?
P and Q.
P and Q, whee, right? It's just saying it at once, right? You're saying premise 1, P is true. Premise 2, Q is true. Conclusion, or line 3, P and Q are both true. Any questions? All right, simplification, kind of the opposite. I call it the simp rule. P and Q, because everyone who uses it is a simp. You can derive two things from this. What can you derive?
P.
You can derive P, what else?
Or Q.
Or Q, or both, right? So if I had, if I was doing this more in the style of a proof, I could say, well, from one simplification, I'm gonna get P, and then I'm gonna do it again, unpack it fully, and get Q. Now, there is actually like a kind of a weird thing about the book.
Yeah, the book
And they
is
don't
only
want you
like,
to do
you
that.
can only simplify for P.
Right, they want you to first have a rule that says, well, this is the same as this, right? Because the order doesn't matter. They're both still true. It's the same exact thing, just in a different order. And so I have to move this to the left first to derive Q from it with a simplification. That doesn't make any logical sense, why that restriction is there. That's one of those things that are one of the purely mechanical, visual things that you want to get it on the left before you derive it. What is that? It's stupid. Okay. Questions on simplification? Okay. Addition. Here's the fun one. I think, did I already explain this another time?
I think you may have
Maybe a
briefly.
little bit.
I think I mentioned it when we talked about you could derive anything from a contradiction. I think we very briefly talked about that. Let me explain again. Okay, so here's addition. If I have P, I can conclude P or, let's just say triangle for anything I want, right? Now I can add, I don't want to put in parentheses. What this is saying is that if I have P, I can add whatever I want onto it if I put an or. Why is that true?
Because only one of them has to be true.
Because only one of them has to be true, so this is a technicality. I know P is true. So whatever I attach to P with an or, I know I'm going to have at least one, because I already have P. So I could just add whatever I want, even if it makes absolutely no sense. And technically, it's still valid. Does that make sense? You want to see an example in English?
Yeah, I'd like to see how that's useful.
What?
I'd like to see how that's useful.
Oh, it's very useful. In the book, especially. They give you problems where you have to add the perfectly right thing. You have to just invent it out of thin air, or you get nothing, right? You'll never solve it. So if I say 2 plus 2 equals 4, let's just say that's P. We all know that's true, I hope. Yes, honors class, okay. So 2 plus 2 equals 4 is true. I can add on to that 2 plus 2 equals 4, or I am the skeleton queen of the underworld or something, right? Now this is not true, I think. And it makes no sense, it has absolutely no connection to this, right? But because this is always true, I know that this statement is technically always going to be true because I have at least one, right? Any questions on how this works? It's a dumb technicality. But here's the problem. What if I have two premises somewhere in an argument, and one says P and one says not P? Well, with the addition rule, why am I doing that? With the addition rule, I say one addition, P or Q. How can I get Q?
If you have not P.
If I have not P, so I'm going to do 3 to disjunctive syllogism, I'm going to get Q. Right? Did I have any evidence for Q?
No.
Q is nowhere here. How'd I get it? It's like a pulling rabbit out of a hat, right? I just pulled Q out of my ass and proved it. Because I have a contradiction here. Now I can add anything I want. Right? As this whole big thing. Can't I now derive, because I have the contradiction here, 2, 5 disjunctive syllogism? Now I've just proved this whole big string of things? See the problem?
So you could in fact prove that you are the skeleton queen of the underworld.
Exactly. Which, hey, if I prove it. So yeah, this is valid. I can validly conclude whatever I want from a contradiction.
It's just not sound.
It's not sound. Why?
Because you can't have P and not P both be true at the same time.
Right. So what's soundness?
It's validity and all
Yeah.
true premises.
Yes.
Yeah.
Validity and all true premises. These premises can never be all true. So will always be unsound. Make sense? Okay. But it's valid. So that should show you that logic does not teach you content. It teaches you how to clearly derive things from other things and models those relationships. But you have to have good starting points, good premises for a good argument, right? So there's more to life, there's more to philosophy than just a series of logical inferences. You have to have data, you have to have good starting points, you have to have coherence, right? Okay, so we got 8 rules. These ones I feel like were pretty easy. Constructive one is the hardest, but these 3 are, I think, these 2 are pretty obvious. This one makes sense after you kind of explain it as a technicality, but are there any questions on the meaning of any of these?
I do have a question. So, is it strictly with the addition, is it strictly, like, if your premise is P, then you can derive P or Q? Or could it be something like your premise is not P, and so you derive P or Q, and then prove that Q is true?
I'm not sure. So if I have not P here, what would you add with the addition rule?
I was wondering if you could do P or Q,
So,
and since you know
that?
P is false, then you know Q is true.
one add like that?
Mhm.
No, you can't do that. Yeah, you have to add it on to whatever you have. So that's fine,
Okay,
right? Now, what would you need to then prove Q?
not P.
Not P or P, yeah, the same thing. Good. Yeah, but you have to add it just onto whatever it has.
Okay.
Yeah. Hey, any other questions? All right. Let's do homework problems. I don't feel like making them up off the top of my head. Raise your hand if you have your book. Okay.
I have the online.
Yeah, that's fine. I guess prioritize people who have the book. Unless you want to borrow my iPad with a book on it, that's totally fine. Okay, 7.2 point. Let's just jump in. 7.2.3. How comfortable are we feeling with proofs? We okay? Anybody struggling with 7.1?
After I went home and did more, it clicked
Good.
after class. So.
Good. Beautiful. Okay, so let's do this. Keep your hand up if you have your book.
Online?
That's fine, yeah. Okay, so 7.2.3, I'm gonna assign numbers. Are you ready? Remember your number because I'm not going to. As soon as it leaves my mouth, I don't know. 5, 6, don't 7, 8, 9, 10, 11, 11, 12, so yeah.
Oh, okay.
13, 14, 15. Okay, let's work for a few minutes on these individually. We'll probably not get to all 10 today? 14, yeah, we won't get to all 14 today, but, start working, try to figure it out, and then we'll see where we're at in like 5-10 minutes. Sound good? Cool.
7.2.3, right?
Mm-hmm.
Try 460. That's the PDF.
your hand if you're done. Yeah, let's give it another minute. There it goes. Okay, how close are we to being done? We like part way into the proof, good enough? Okay, let's start with some of the earlier numbers and just have someone volunteer to come up and do it. And then you can keep working or you can just put it on hold. And then if you've got an incomplete proof right now and you still want to come up, we can all do it together and walk through it. In real time, live, on the board. All right, who's first?
I think I was, I'm fine.
Yeah, come on up. Here is a pencil, or a pen, whatever you want to call it. Same thing. No.
So I figured there were kind of a couple ways to do it, depending on like how specific you wanted to get. So one, we've got this is what we're trying to prove. So we've got G, then S and T, and then S or T, then J, and then we've got G, so J. So what I wrote, first we have S and T. That's 1 and 3. Modus ponens. And this is the part where I was like, you know what, for the sake of we just learn these rules, I'll be real specific with it. So I said we have S, we have 4 simplified, and then 6 with S or T, we got
Good.
5 addition.
Good.
And then 7 is where we conclude
Yeah, perfect. Great job. Yeah, that's really good. Okay, then that's it. That's all. Good. That was great. Good job. Okay, who's next?
I have number 6, but I already did go today, so I feel kind of bad.
We can skip you. That's fine.
Take the spotlight. Show us how brilliant you are.
Yeah, come on now. Come do it. Let's do it. We do a numerical order. That's fine, isn't it? And you can write anywhere you want on the board. Erase whatever you need to. I think.
He left the board dirty.
That's true. Okay. It's a little bit rude, isn't it?
Honestly.
Just a tad.
Okay.
Was indeed that.
Oh, I erased your stuff too.
Oh, I don't care. You can erase all of it.
Okay.
Wow, a totally clean whiteboard.
Isn't
Yeah,
it
those
perfectly?
smudges are bad. That eraser needs to be replaced. I wish we had those digital whiteboards. It would be so cool.
Oh, the smart boards?
Yeah. UCO down in Edmond has the library is like full of them in servers. That's so cool. I used to just sit there in undergrad and just like do logic for fun by myself because the boards were so cool.
I remember the first year we had smart boards in school. I was like,
It's amazing, yeah. This is revolutionary.
And like woodcraft. Okay. So from 2, I can simplify and just have L.
Good. Oh, being all fancy.
Oh, I forgot, sorry. And then, since I have L, I can just randomly decide to add on a T.
Good.
So that's 2. I don't know why I decided to, okay.
It does not matter. But you have nice cursive.
Thank you. From this, I have modus ponens, and I have B and G.
Good.
So that's. We can simplify 6, so I just have B. I simplified 5 though, but yeah. And then I can do a conjunction of 3 and 6. And
Nice.
get my conclusions.
Good job. Great. Would it have mattered if you would have done B and L in that order? Would it have mattered if you conjoined B and L together, but B was first and L was second?
to the book, yes.
To the
But-
book, yes.
But to us, no.
Logically, no.
Yeah. It's the same content, right? And funny, like when you get beyond this, the impression of logic the book gives you is that it's all neat and tidy and we all agree on these same rules. We do all agree these rules are true, that they work, but it's much more messy and loose. And when you talk to mathematical logicians and mathematicians who do logic and philosophers who primarily do logic, their stuff's crazy, disorganized. I hate them. I've mentioned it before. I hate them. I wish they're more organized. Anyway, that's great. Good job. Yeah, you got a snap for him too. Good. Okay, going on too long. The second too long. 7, right?
I think it's a good word for you, Dylan.
Thank you.
Yeah, see? Nice thing. They'll give you a flower too. Apparently, he hands it out.
Next time Noah goes up to the
No, we're gonna have to move your cursive.
No, yours is better. I've
You
seen
guys are such
They're big
nerds.
enough? They're good for everybody?
Yeah, that's great. F, not F or X.
Yeah.
You have to copy down your drawing on top of that too.
This guy?
Both of them, yeah.
Alright.
There you go. Now that's an authentic reproduction of the state.
Want this guy too?
Nah, we can save it.
Alright. Alright. So, we can get not F from 2, 3 modus tollens.
Good.
And you can get not F for X from 4 addition.
Good.
And you get P or T from 1, 5 modus ponens. And then you get T from 3, 6 conjunctive syllogism.
Good. Good job. That's great. Fast. And good drawing too.
Thank you.
I like your drawing.
One thing that like confused me was the addition one.
Yeah.
Just because, I don't know, I felt like, do I need the addition? Because I felt like with not F, right, it makes this part true.
Okay, so good. Describe how 4 alone makes the antecedent of 1 true. So 4 is not F. How does not F make the left-hand side
Oh.
of 1 true?
Okay, because you have at least one of these that are true, which makes this whole statement true,
Right.
which then makes this true.
Right. So if you were able to affirm the left-hand side of 1, right, what would affirming the left-hand side of 1 look like? Well, it would be saying, well, not F or X, that is true. But 4 alone would make not F or X true, because it would give you at least 1. So then you get the right-hand side. And then I guess you could say that would be a new form of modus ponens. But in terms of how modus ponens is written symbolically in the book, technically it doesn't work, right? You have to first do that addition step. But you're absolutely right in terms of content. And that's like the important thing I want us to see. So if you just didn't do the addition step and you said 1, 4 modus ponens, I'd give you full credit. If you wanted to define a rule that looked like that, what would the rule be that would let you do that? Like the general form of the rule.
It would be like a combination of like modus ponens and disjunctive syllogisms, at least in that example.
Yeah, how would you specify that though generally? To make it, basically, these rules are axioms, right? In a sense.
You could say like A or B, then C, and then the second one is A, then C.
Okay, yeah, exactly. Or you can use shapes or however we want to do them, right? Yeah, yeah, you'd have to define that disjunction in there, right? So it almost looked like a new form of disjunctive syllogism. Good. Yeah, but Dylan's absolutely correct. All right, who's next? 8?
I had A.
And don't touch that man.
I'm not alone.
You're gonna leave that man.
Is that how you feel doing logic?
So I think all my classes.
Yeah, that's fine by me. I'm not trying to make you happy. Trying to make you logical, which are often the opposite.
Is that like dark enough, everyone?
I can see it.
Okay. That's all that matters, right?
Yeah. Good enough.
So we have Q, and that means that we have NVO,
Cool.
and that's through 2, 3 modus ponens.
Good.
And then through like the CD rule, I don't remember what that was called.
Constructive dilemma.
Yeah, through that one, if we have NVO, then we also have B, then or B and C, B or C. My bad.
Good.
And then that's 4, 1, C, D.
Good. And that's it. Wow, yeah, that was, dang, that's quick. Good. Good job. Any questions on this one? Yeah, see, look, learning by example, Colin. He's erasing. Good. Your kindness. Your
It's like
kindness.
change the world.
Yeah,
It starts with one whiteboard.
exactly.
One very dirty whiteboard.
But really though, you ever think of why it's called a whiteboard? Why is it so exclusionary? Why not another ethnicity? Alright, who's next? 8, 9? 9? Who was 9?
I think it was me.
Come
We
on.
need some assistance, I think.
It's okay.
So,
We all need some assistance in some ways.
Yeah, but I might need assistance on the proofs, so we'll see.
Well, yeah. That's what we're here for.
Indeed. Okay. Also, excuse my handwriting, it's pretty terrible, so.
Oh, that was fine. Just be modest.
See, Sophia, how he avoids the whole thing with the arrow.
That's what I'm saying.
If y'all haven't realized yet, I'm a perfectionist.
No, I'm right there with you. I understand.
Yeah, so you can hush.
You need to write some fancier arrows then. They need to be perfection, like cool, like have intricate designs in the middle of them.
You
I
can't
said
say
I was
that
a
to
perfectionist, not an artist.
But can you have perfection without beauty, Sophia? Oh, got ya. And can you have beauty without art?
Sounds like we could write an argument. on
Yeah,
that.
that's for another day.
Yeah. Okay, so you got 4, 2 simp. Yep. 5, 4, 1 modus ponens. Okay, so that's exactly what I was just talking to Dylan about, right? On 5.
Yeah,
So
'cause
that
you don't have
technically
to
goes
have
with-
the,
Yeah, you don't have to add W if you don't want to. Technically, the book will make you again, just to be super clear. But yeah, you don't have to, so that's completely correct. 6, you got not R. 3, simplification, good. 7, U and not T. Where are you getting 7 from?
so we have U, right?
Mm-hmm.
And then we don't have R, and then up here, or right here, we have T then R, but if we don't have R, that means we don't have not T, or we
Right.
have not T.
Okay, so,
You have to add a step to say that?
yeah, first get not T there. Yeah.
Okay.
So 7, erase 7, and 7 should be just not T alone. And what rule would that be?
That's a question.
Well, you said it correctly, right? What lines are you combining to get not T?
Combining 5 and 3, or 5 and 6?
5 and 6,
Yeah.
good. So you can just put 5, 6, and then MT, modus colon. Good. But again, like, you know how to do that.
It's just the,
You just described it. I don't care about the name. So you can just say 5, 6. As long as you know it, golden. So now what do you do? Your last thing.
then don't you just write the conclusion down?
Yep. Yeah, you write the conclusion. How are you going to do that? What lines are you going to pull from?
7 and 4.
7 and 4, good. And you just conjoin them together?
So would you write 8 as a step and then write, okay.
You would write, yeah, so you would just write 8, and then you just go U and not T. And then that's,
And would you
yeah.
have to write the justification for that, for
Yeah.
4 and,
yeah, you have to do
7.
4, 7, conjunction.
okay.
Yeah, and then that's it. Yeah.
Alright.
And it's valid. Good job. Yeah. See, you didn't need assistance. You were doing it that's perfectly fine.
It's just a lot of words, man. Like modus ponens, I don't know. That's.
And it's like showing your work for math, like we know how to do.
Oh, I don't do that.
Yeah.
And I was.
Dude, I could never do math unless I showed my work, because I like couldn't, I had to do every single step of everything. Good job, that was good. What time is it?
2:25.
What time do we get out?
We have like 20 minutes left.
Okay, thank you.
What do you want him to be named?
I don't know.
Ten?
The first name that popped in my head was Fred, but he really doesn't look like a
No,
Fred.
it's not Fred. The nose.
Yeah, he has a big nose.
Bartholomew?
I was thinking Bernard.
Bernard's good.
I like Bernard.
Is he our mascot?
Yeah, that's a logical mascot. That's what it looks like when you get
into
confused.
class, you're gonna have to draw him now.
Start giving him outfits, so he's like naked up there.
He is naked, how immodest. Scandalous.
You don't need to be dressed to do logic.
That's true.
You could do it in a bathtub.
I'm almost never dressed when I do logic unless I come to school.
It's all those shower thoughts.
Yeah. Logic is the most sensual of the discipline. See, so we have another technique of drawing the arrow that doesn't involve.
When I do number 12, we'll try a few things out.
Okay. Good with you. Okay, D or E, then G and H, G but not D. So D or E. T and F, M, okay. So simplification should be good. 5. Good. Okay, nice. So this one relied on the principle that you can prove anything from a contradiction, right? Where's the contradiction?
And 5 and 8.
5 and 8. And then that lets you do the addition and finally get M, yeah.
Yes.
So,
And something that wasn't even in the premises as a conclusion.
right, exactly. Just something completely unrelated to the premises, yeah. So, what that tells you, valid but what?
But not sound.
But not sound, because premises could never be true. There's somewhere hidden in there, even though it's not explicitly written, somewhere in there is a contradiction, an inconsistency. Good, that's great. Perfect. Everybody snap one. All right? Cool. God, I like that. Power. Okay. 11?
So I have a question.
Yeah.
In general, if you see the conclusion is a proposition that wasn't anywhere in the argument, is that a pretty good indication that there's I forgot the word, but
A contradiction. Yeah, it is an indicator, but it's not necessarily the case. Because you could have a premise that says P or Q, and another premise that says, oh wait. Okay, it's an indicator that's a contradiction except for when the conclusion is itself added to something. So if you have a premise that says P, and the conclusion is M, P or M, where'd M come from?
That's just an addition.
Right, but if it's by itself, then it must be.
Okay.
Yeah, I can't think of an exception. BRF, then A then G.
Oh my gosh, can you like talk or something? I'm getting nervous.
You're not gonna make a mistake just writing.
No, I'm just like, it's so quiet.
Noah,
Consuming.
anything of interest to talk about? Do you wanna talk about like
Yes,
arrows
thank
some
you.
more?
No, you said something of interest.
Oh.
My friend.
I was about to compliment your E. It's a nice E.
Yes,
Oh
that's a
my
nice
gosh.
cursive E.
Thanks compared to everything else.
It kind of like reminds me of the Eggos E.
I like Eggos. Those are pretty cool.
I haven't had an egg in so long.
Oh, okay. So that's cool. I forgot what I was doing. Okay, so that's not it. So then that's it. So
Yeah.
that's cool. And that's oh my gosh. Sim.
Good.
Okay. And then B for F. That is one for modus ponens.
Okay, wait, hold on. How'd you get that?
I'm gonna be honest with you, I don't know.
Okay,
But-
so that doesn't work.
Okay.
So modus ponens, you have to affirm the left-hand side of an arrow and then you get the right-hand side.
Okay.
But you can use 1, 2, 3, 4. On 4, you can add or F to it and get
I
that.
should remember these.
Yeah. So you can keep B or F there, but then you would just say for addition.
Okay, that's what I thought originally, but then I changed it.
Yeah. So you can just add F to the B with an or sign.
Okay.
Good. Okay, so now that you have B or F, what can you do with B or F?
You can do a little disjunctive syllogism. So that's not F, because we know B.
Nope, that doesn't work.
No.
You have to negate B to do it.
Oh, okay. Dang, I really don't
It's
know what
okay.
I'm doing.
It's okay.
Okay. And yeah, the rest of it's wrong.
So let's look at premise 1
Okay.
and premise 5. Do they have anything in common?
No.
What do they have in common?
B or F.
Good. So premise 1 says B or F implies A then G.
Okay.
Well, if I have B or F, then what can I get?
You can get A or G.
A then G, yeah. So we could do 1, 5 modus ponens, and that would get us A then G.
Okay. Work.
Good. Okay, so now we've got A then G.
Okay.
What can we do from there?
Good thought. So we could move on to like line 2.
And line 2, yeah, how could we get B or E? So if we want to do the same thing, we need to get B or E to do a modus ponens on 2, right? How can we get B or E?
Okay. I'm about to do the mock right now, I really don't know.
Here, look at number 5.
Okay.
That might help.
How do we get B or F from just B?
You just added it?
Yeah, you just
Okay.
added it.
Okay.
So you can just pull it out of thin air.
Okay.
Yeah, there you go. And that would just be 4 add again.
Okay.
Cool. And then now what could you do? Now that you have B or E, how can that interact with 2? Good, G then K. Good, good, good. And then what rule is that?
That would be most students.
Good, yeah, most fun. Good. So we've got G then K, we've got A then G. How could we get that conclusion A then K?
6 and 8.
6 and 8, yeah, good. So what would that end up being? Like what rule would it end up being? It's okay if you don't know the name of the rule. Describe the reasoning there.
Because it's like, well, it's not a sequence, I guess it would just be like a little conjunction moment.
Yeah. So if we look at 6, right? What's 6 say?
A then G.
And what's 8 say?
G then K.
So if A gives you G and G gives you K, then doesn't A give you K? Right? So you can just put A then K.
I got so small fingers at the top, oh my gosh.
You're fine, you're fine. And that'd be just 6, 8, and then the rule name is hypothetical syllogism, or HS. Yeah, good. Okay. And then there you go, that's valid. Exactly. Okay, cool. Everybody snap. Yeah. Oh yeah, shut up. Okay. Good. Any questions on that one? All right. 238. Get one or two more. You got? Right?
I have 12.
You've got 12. Come on. Let's see these arrows in action.
Alright, so premise 1. Gosh, this marker is crap.
I just found you.
Oh,
I
wait, it
forgot.
might be a bit better.
Yeah, that's good.
I can make it.
Nice.
Thank you.
The snapping. I'm snapping. Cracks me up.
There's a reason I'm an honors kid. I'm not an athlete. Okay, let's try it. Oh, look at that. Okay,
Isn't it beautiful?
it
Brand new
is.
flag.
That's gonna stain the board so bad.
Oh yeah. It's actually a Sharpie.
I don't know about those arrows.
I don't think that the horizontal line quite lines up with the middle of the wedge.
Yeah, that's kind of a problem there. It's not perfect. You know, you can just tell as she's drawing it that, like, it makes her uncomfortable to be adopting that type of arrow.
It really is. It's bugging me.
You can do it however you like. Don't let anybody tell you you can't.
Uh-huh.
But these are also the best way to do them.
I think all those arrows look really great.
Thank you.
Wow, how nice. What a relativist.
Yeah, that wedge at the bottom though is rough.
Yeah. I agree. And what's the check mark between P and M on 2? Oh, I see. Okay.
Alright, before I solve it, any guesses to how many steps there are?
Wait, which one is this? 12?
12.
7.
We're thinking 10, 7, somewhere there? Alright. So first we're gonna do P to R. And we get that from 2, 3 modus ponens. So if we look at that, so yeah, we've been given P or M, so since we have that and that's true, therefore we have P then R, which is number 4. Pretty easy. So number 5, we're gonna have M to P, then P, which comes from 1, 4 modus ponens. So if we look at 1 and 4, oh, we have P then R now. Okay, that's true, and that gives us M then P. Wow, so easy. Then we look at number 6. We're gonna get P, then R, and M, then E. And we get that from 4 and 5 from making them a conjunction. Conjunction, junction. So yeah, if we look at 4 and 5, wow, you know, they're both true on their own, we can just combine them. And then we can get R or P from 3, 6, constructive dilemma, or whatever it's called. So if we look at 3 and 6, okay, so we have P, we have this whole combination. So we've been given P or M right here. Oh, okay, so now that we've said that we have this, we can say that we have R or P, which is our conclusion.
Good job, that's great. Good. See, just because somebody can't draw arrows doesn't mean they're not good at it.
It's okay, Sophia. Truth be told, I can't draw arrows, and that's why I use the horseshoe.
It's okay.
But I also
No, that's great. Well, doing good.
Backwards C.
All right. We've only got 3 minutes left, so let's just call it there. We're on 12, right?
Yeah.
Yes.
12? So there's 2 more. Remember next time. Remember, and we'll start with the next episode. Any questions? All right, get out of here. See ya.